So hello everyone, I am Srushti Valte from third year electrical engineering department, and I with my friend Shraddha Nare, we are performing our CI activity of power electronics under the guidance of Dr. Vijay Kumar sir. Let's start. We are performing the simulation of buck converter with closed loop feedback using PI controller. So in this video, we will see the step by step how to perform the simulation of buck converter using PI controller in MATLAB Simulink. So now I will open now I have opened the MATLAB software. So to run the simulation, I will click on the Simulink tab. Okay, now I will click on the blank model to create the new model to run the simulation. Okay, now I will click on the library browser to browse the components that I need to add in my simulation. So at first I will add the DC voltage source to the screen. So in search bar I will simply search for the DC voltage source and I will click on search option. So here the DC voltage sources appear and I will add to the screen. So as we can see that this voltage source is been added to our screen. So I will simply move it. Now I will double click on this and the input, I will set the input voltage. I now have set the 12 volt input voltage value for this voltage source. Now the next component that I will add is the MOSFET. Next switching component, that is MOSFET. Now I will search for it. Okay, now I will add this MOSFET, this block. So I will move this here. Now I will connect the positive terminal to the MOSFET. Okay, now the next component that I will add is inductance, but I will search for the series RLC branch and then I will convert it by changing the branch type. I will first add this. Now I will double click on this to change the parameters. Then I will change the branch type to L, set the value for this 6 millihenry and I will click on OK. Now I will connect this MOSFET to the inductance. Now next I will add diode to our circuit. I will search it. Now I will add this diode. I will press Ctrl R to rotate it, move it towards the MOSFET, and I will double click on this and I will remove this option to show measurement port and click on OK. Now I will connect this terminal to the circuit diagram and the next terminal of diode to the negative terminal of source. Next I need to add the capacitance. So simply I will copy this inductance and paste it. Now I will press Ctrl R to rotate. I will again double click on this, change the branch type to the C and change the parameters. To the microfarad. Now I will click on OK. Again I will connect this inductance to capacitance and capacitance next terminal to diode. Now I will add the R load. Again I will copy this capacitor and paste it. Again I will double click, change the branch type to R, set the value to 10 ohm and click on OK. Now I will move it. Now I will connect this will connect this to the capacitance, across capacitance. Okay, now next I will add the voltage measurement to measure the output voltage. So I will add this block and I will connect this across the R load. I'm sorry. I will connect this across R load. Okay. This next terminal over here. Okay, now I will add scope to display the waveform that we get from output. I will connect the scope to the output terminal of voltage measurement. Now the last component that I will add is power G1. This is important because we need this to run our simulation in the MATLAB. So I can place it anywhere on the screen. So this is the final circuit of buck converter. So further, to add the PI controller, whatever component we need, the step by step it will be explained by Shraddha.
To design the closed loop buck converter, first we need to constant block having the reference voltage of 5 volt. It is because we want the output voltage of 5 volt. To take this block, go to the Simulink library and simply search in the search bar as a constant. Now double click on this block and put here and 5 volt value, press OK. Now we need to connect the subtract block, search it in the search bar and add it into the screen. Connect the constant block to the PID controller, terminal of subtract block. Now need to connect PID controller block. It should be noted that here we have used discrete PID controller. Again search it and break it into the model. Double click on the block, click on discrete time in order to make it discrete controller. Now here I am using a PI controller, so I will click on the PI and press OK. Now we need to connect pulse generator, search it in the search bar and bring into the model. Connect this block to the output of PI controller block. Double click on the add parameters. Switching frequency of buck converter model is 25 kilohertz. Put it in the box and press OK. Now connect the output of this PWM block to the MOSFET gate pulse and input and second terminal of subtract to the output of buck converter. Now we need the display block to the C values. Search it and bring it into the model. Connect the display block at the feedback loop. Set the time 1.0, and now at this stage model is completed and we can run the simulation. Now click on the run button to run the simulation. and this is the output waveform that we get from the simulation of buck converter using PI controller.